Okay, so we looked in the last video. Sometimes when you eliminate a haloalkane to form an alkene, you can get two different products. Now with this one, you can see you can get three different products, and some of those can also exist as two geometric isomers. So let's have a look at this. So we're going to start off with this compound here, which is 3-bromo 3-methyl hexane. Okay, 3-bromo 3-methyl hexane. Right, now when you eliminate, you always eliminate the bromine, and you remove a hydrogen from the carbon next door. Okay, so let's see with this red one, we've got, I'm going to colour, let's say we're going to remove that hydrogen there, I've just coloured in there, okay, from the methyl group on carbon atom number 3. All right, so if we eliminate that, what is the product we're going to get? Well, it's going to be this, colour code it here, it's going to be this red product. We're going to end up with a double bond there, aren't we? Yeah. Okay, and we'll put the hydrogens on everywhere. So 2 hydrogens there, none on the middle one, yeah, and so on. Okay. Now you can probably see, well, can this one exist as EZ isomers? Two geometric isomers? Well, it can't, because if you look here, we've got 2 hydrogens stuck on there, yeah. So on that side of the double bond, so if you swap them around, it doesn't make any difference. So no, that can't exist as EZ isomers. Right. So now let's think about what happens if we remove. Right, I've got a blue one up here which I've drawn. Okay, let's see. Let's, instead of removing on the carbon next that one, let's say it removes it from this one here. Okay, so we're going to remove a hydrogen there. So now the double bond is going to form between those carbons, number 2 and 3. So we're going to get that product there, aren't we? Put the hydrogens on here. All right, none on that one. Now, can that exist as EZ isomers? Well, it can, because if you look at the double bond, right, so I'll draw the double bond here. Right, what have we got attached to this carbon? Okay, we have got a methyl group and a hydrogen. Yeah, so we want CH3 and an H. Well, what have we got attached to this carbon? Well, we've got a CH3 and a C2, C3, H7, a propyl group. So you can see that isomer I've drawn there, well, I think you'd be tempted at first to say that is the Z isomer, but if you think about it, it's actually not the Z isomer, because we've got to label the highest priority group. Highest priority group there is the methyl, because that's the biggest, the heaviest. The highest priority group on this side is the propyl, so because that's heavier. So the 2 high priority groups are on opposite sides. So what I've drawn there is actually, that is the E isomer. Okay, and that can exist as a Z isomer as well, can't it? So let's do the third possibility. Okay, so this time we are going to remove a hydrogen from this carbon here, this one. Right, so if we do that, remove that hydrogen, and we're going to get this green molecule here. So we're going to get the double bond being formed there. Okay, so if I put in the other stuff, so I'll call that CH3. Right. I'm missing a carbon there, aren't I? Need another one. Put a hydrogen there. Okay. Now, let's see. Can this exist as 2 EZ isomers? Well, I think you probably see that it can, because we've got different things around that double bond. Let's draw the double bond like that. Put it in a 120. Right, this carbon here, what have we got here? We've got a methyl group, and we've got an ethyl group, C2H5. This carbon, what have we got? We have got a hydrogen, and we've got an ethyl group. Okay, now they're both ethyls, which are the high priority groups, are on the same side, so that one is the Z isomer that I've drawn there. Okay, so you can get three different structural isomers, and of those, well, the blue one can exist as two stereoisomers, and the green one can also exist as two stereoisomers, so that's going to be 5 products. Right, let's have a go at doing that with skeletal formulae, shall we? Okay, so I've got the skeletal formula here. I'm going to put on the red hydrogen there. The blue hydrogen is here, and the green hydrogen is there. Okay, so let's draw what would we get if we did the blue. Right, let's do the blue one. So it's going to be, that's not blue, that's red. It's going to be the same sort of skeleton. The double bond is going to be here. Okay, now what I've drawn there, you would probably call that, you've got that methyl and that propyl on opposite sides, the two high priorities. So that would actually be the E form. Okay, let's draw the Z form. The Z form you draw like this. Right. And then I would have to draw that bond like that, and then the rest of it. Okay, so that's the Z form. So that's, I need to put the methyl group on there as well, don't I, which I'm missing. The methyl group goes there. The methyl group goes there. Right, let's do the red one. The red one, so I'm going to have like that. 1, 2, 3, 4, 5, and 6. This is a bit easier to draw, this one, isn't it? Because all I've got to do is put that there, double bond there. Okay, and that can only exist in one stereoisomer, because you've got 2 hydrogens on the end there. Yeah, both the same. Let's draw the green one now, finally. Okay, so right, so I need to draw the double bond 1, 2, 3 between 3 and 4. So I need to draw it there. You can see I've got the 2 high priority groups. I've got that and that on the opposite side. So this is the E form. So I'm going to draw the Z form. So I need to draw the opposite arrangement around that double bond, which I haven't done. Where's my double bond? I'm going to rub that out, and I need to do, what do you think? Right, I need to move it down a little bit, don't I? I need to move it down a bit because I'm going to run out of room. So I'm going to do that. Let's move that down there. Right, now I need to rub out that bit. To rub out that bit and stick it up the other way. So if I do that, let's get rid of it. And that goes up there and there. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay, and then I need to put the methyl group, which I've forgotten about. So that goes on. My phone's going at the wrong time here. The methyl group is going to go on number 3. 1, 2, 3. There. And it's going to go on there. Okay, so that one there is the Z form, and that one is the E form. Right, we should probably try and name those as well. Okay, let's have a look at this. Let's look at the blue one. Right, we've got 6 carbons, haven't we? We've got a methyl group on number 3. We've got the double bond between 2 and 3, so it's hex-2ene, but it's 3 methyl hex-2ene. Okay, that's 3 methyl hex-2ene. The red one, now that is difficult to name because you've got the double bond here, so you're probably going to have to treat this as a sort of substituent, yeah? Right, and we call that 1, 2, 3, 4, 5. So we're going to call it pent 1-ene, and we're going to number it the other way around. So it's 1, 2, 3, 4, 5. Pent 1-ene, and we have got an ethyl group on number 2, so we'll call it 2-ethyl pent 1-ene. They probably wouldn't ask you to name one like that in the exam. I don't think I've ever recalled one like that. Whereas this one, okay, this is 1, 2, 3, 4, 5, 6. This is 3 methyl hex 3-ene. Okay, so variety of different compounds there and different stereoisomers. All pretty complicated. We've got a lot of different isomers being produced from one starting material.